there's no authentication of users, and there's no encryption of data as it moves around, right? We're an open system. Anyone can connect to the repeater if they buy a piece of technology, tune it to a frequency, and hit a PL tone. They're in and they're communicating. Sometimes non-licensed people, there's nothing to prevent them from buying a radio, connecting to the repeater and talking, or even talking simplex to each other. So security is really, I started to think about that. Security is not really a mindset in ham radio operations, right? When we're using our radios, we're not thinking of, oh, what is the security impact of what I'm doing, which is fine because it's radio communication. But when we take that into the mesh networking realm, where we're connecting something in the ham frequencies to a data network, maybe your data network, to use an internet connection or provide a service, well, then some security considerations I feel strongly about should be implemented. And that's what today's discussion is about security topics that relate to mesh networking. I gave everyone a handout. If you have the handout in front of you, there's front and back, 2 pages. What I first drew on the diagram is kind of a mesh network, really. The little boxes could represent a Linksys running the mesh networking firmware that's available out on the internet. Anyone who has a Linksys router can flash that router with the new firmware and enable the pre-configured and pre-compiled, if you will, firmware to run a mesh network. So many of you have APs at home or have bought an access point at home and connected it to your network. And then when you start it up, you have to pick an SSID, a network name, and you have some basic password stuff. You have some encryption stuff that you configure, right? With mesh networking, what a group has done is they've created a firmware build that has standardized on an SSID, so that if you can go and you can download the software, load it on a Linksys, drive to California, power it up in your car, and if you're in radio range of another mesh node that was built the same way, you'll just connect. Why? Because a lot of the parameters are pre-programmed into the firmware. So that's the benefit of it. The whole benefit of a mesh network is, hey, I can show up, if I can hear and transmit, I'm participating. Well, that's awesome, right? That's great. If all of us had that router on our desk right now, we could load that firmware, do some very, very basic configuration, which is basically configuring your node name. All of a sudden, all the routers would talk to each other, and we could plug in an email server or a voice server for voice over IP. We could run internet browsing across that network, right? So that's good, but it can also be bad because we might not be thinking about what that means from a security standpoint to what we have connected to our network, okay? So when you're implementing a wireless network, you come up with your name, you change your default passwords to other than default, you configure Wi-Fi protected access with usually a pre-shared key, a passphrase that you have to type in. You select an encryption type. Very popular today is the AES encryption for encrypting the transmission as it gets transmitted over the air. And then because of the openness and the pre-configuration of the mesh networking software, that's really not available to us. So a lot of the tools that we would use to secure a wireless network are not there in the mesh networking world because, well, 2 reasons. One is because it's not pre-configured that way, and then the other reason is Part 97 of the FCC rule says we can't encrypt our transmissions, right? So right away, well, encryption's off the table. So I can't encrypt that wireless communication between nodes. So anytime that you connect 2 mesh nodes or more mesh nodes, you're creating that network that can be used to transmit data, okay? Which is the goal, right? but we always have to remember the regulations that we have to abide by. Okay, so on your little sheet here, so the first thing about mesh networking is it's standardized fixed SSID. The user types in their node name, and there's this protocol that runs, and the nodes share information, so all the nodes know where each other are. Right? That's a protocol, a routing protocol that runs on the mesh node, which is great because again, what that means you can get the router, load the firmware, and then you're up and connected. Now we put my security hat on and say, okay, well, the first thing I want to do when I build a mesh network is I want to connect it to something so I can run data across it. Well, that's the most fun part, right? So we have a ad hoc data connectivity tool, right? Which is fine, but my instinct might be, hey, I'll just plug it into my network at home, and then I can get to the internet. And then, if another ham is near me, they don't even have to call me or talk to me. They can have their firmware loaded. They might even have it in their car, and they can drive around and connect. And then they could get to the internet from my house, right? That might be a bad thing. I think Part 97 of the SEC rules says that both ends of the communication have to be licensed amateur operators, okay? So one thing that you do, if you plug that mesh node into the internet, you've not only enabled the ham to come through the mesh wireless and get out the internet, but internet users who aren't licensed amateurs can originate and source traffic and send it back across. That might not be what we want. So what really needs to happen is there should be tools put in place to prevent traffic from passing in that case, right? So a mesh network uses a peer-to-peer communication that needs no authentication of username. I don't have to log into anything, right? I can just listen, hear, transmit, and receive, okay? So one of the first and one of the strongest things that you can do on an information system to enhance security is to change default passwords, right? So every node on a mesh network can talk to every other node. And then once I have a mesh node and I connect to a mesh network, I could then, because it's all TCP/IP based, right? I can access any other node. And if you don't change your default password, every other ham that connects to your node knows your node name and they can connect to it. That may or may not be a bad thing, but it's there. So changing the default password is very important. And if you go through the setup in the firmware for the mesh nodes, it guides you through that. So the other thing to think about is that the mesh nodes are all talking to each other and they're sharing routing information. So this whole, how the mesh network works is if I'm connected to Ed and Ed's connected to John and I'm talking through to John, if we're all in radio range, we can hear each other. I know that John is one arm away from me, and then Ed is one arm away from me, and Ed knows that John is one arm away from him. And so there's an interconnected protocol that runs that helps traffic get from one point to another. So if one mesh node goes away, that protocol makes adjustments so the communication can still happen, okay? So the bottom line to that is a mesh node will connect. It will provide a data connection as long as it can hear and transmit to another mesh node, okay? So it's a very open thing. That's what we like as hams. The link at the bottom of the first page, okay, is the link to a Raspberry Pi build. And it's a build of a Raspberry Pi that can provide most of the security features that you would want to enable and that we often enable on large networks, okay? So if you flick to the back side, right? Some of the typical risks involved with data security are that you could have unauthorized access to your network. through either default accounts, unknown nodes, and someone could even launch attacks on other networks from your node because you're connected to data. Okay. One thing that people think was like, okay, well, I connect this mesh network to my home network. I don't have anything on my home network. What do I need to worry about, right? But if you think about it, the second risk is really lost or stolen information. How many of you do your taxes on your PC at home? You have tax information on there, Social Security number, your address. This is identity theft targeted information. Not all amateur operators might not be on the up and up. Or somebody who's smart goes and gets the firmware and connects to a mesh network, and if you've plugged it into your home network, well, they can reach through to your Windows machine and exploit any bugs or security holes that are in that machine, right? And then loss of availability. Loss of availability is just, my node doesn't work, someone being malicious and taking my node down. These are some of the risks to your network if you connect a mesh to it. So then the question becomes, well, what do I do? What do I do if I want to run a mesh network and have connectivity? How can I do this effectively and not expose myself to some of these security risks, right? Well, there's four main practices for that. And I brought markers so I could just draw some as we talk, okay? So the first thing is that what we would want to do is, and this is very popular in the corporate arena, is we want to try to isolate the untrusted network from the trusted network, right? If you look at the drawing on the mesh network in the back, well, the one in the front doesn't have a firewall. It just has the mesh network with some services down here. Could be a phone, could be a server. That's great stuff. That's not got any control or filtering in it. The second drawing on the back page shows there's a little firewall in there. And it has some SSH ability, network address translation, give out an IP address, a DNS address, and maybe even running Snort, which is a intrusion detection, open source intrusion detection product. Okay. So what we would want to do is to move to isolate that untrusted mesh network from our trusted personal network by using some kind of firewall device. That firewall device should be placed in between your network and the mesh. So we have the mesh network here, right? And here's all these guys can see each other. And I have an Ethernet node. And this could be my home network. And it goes out to the internet, okay? So placing a device here, we can draw it as a firewall, can give us the ability to separate and isolate physically and logically the mesh network from our personal network, right? Because that's what we want. So isolation is the first method that you can employ to secure your mesh network from your personal network. The other thing is practicing good vulnerability management. Vulnerability management means if I'm at home and I've got a PC and it's running Windows XP, well, that's a pretty bad thing right now because Windows XP is not supported anymore. There's bugs that are exploitable in Windows XP. So one thing that I would want to do as a computer user in this scenario is I always want to have my stuff updated as much as possible. Actually, as soon as possible would be optimal. Security engineers all over the United States on a daily basis look for new vulnerabilities that their systems, that can be exploited on their systems, and they patch as soon as they can to fix those, okay? So isolation is your first tool, and then practicing good vulnerability management is your second tool. Let's say that I left my cell phone sitting next to John, and John wasn't a nice guy, and he could grab my phone, he could plug it into his Macintosh, he can jailbreak my iPhone, and he can put an app on there that copies him and all my text messages. I come back an hour later and pick up my phone, it looks the same to me, and I start using it and I start sending my text messages. What's one of my best steps to fix that or to prevent that from happening? Well, you can't prevent it because it happened, but if a new code update comes from Apple and I load that code update, it's going to redo my phone, and then that jailbreak won't be valid anymore, and I won't have that vulnerability anymore. So patching can either prevent something from happening because it fixes a bug before someone exploits it, or if you've been exploited, it can fix or shut down that exploitation, okay? So patch management and vulnerability management, and patching up to date, having an anti-malware or virus protection suite on your computers, and keeping the operating system up to date is a very, very strong tool that you can do. And it doesn't really cost you anything because you've already purchased the software or the operating system. It's just a matter of taking the download, and the only bad thing is sometimes the download breaks things, but that's that's another story. Okay, the third thing you can do is use some application layer defense mechanism to help filter and control traffic. Now that's what the firewall comes down to. So with a firewall is a tool that provides a physical separation between an untrusted network and a trusted network, and it filters traffic. Now the mesh nodes themselves, the build for a mesh node comes pre-configured. It has network address translation built in. And it's a very, if you've ever had to do port forwarding on your router at home to get anything to work, it's the same facility, it's probably the same code, all right, that they're using in the mesh build to provide that to the mesh network. That, in my view, and everything that I've seen in practice, isn't really enough to isolate you. That's really for mesh network functionality more than personal security, right? So what your firewall can do is it can filter traffic and say only certain traffic or traffic that you configure can go into your network or come out of your network, right? Because one of your vulnerabilities is, oh, I put up a mesh network, I plug it into my house, I'm not even on the internet, I think I'm safe, but all the computers in my house, my computers, my phones, my thermostat, my little Google voice thing, your refrigerator, if it has an IP address, anything with an IP address is now vulnerable, right? So a firewall can be configured to only allow traffic from one point to another, okay? So preserve isolation of the untrusted network from your trusted, practice good vulnerability management, keeping things patched up, and third was using an application layer defense for your exposed network. And then the final thing to do that is extremely important with securing your network would be continually monitoring traffic events as much as possible, right? So you go through all this effort, you come along, you build the mesh network, I build my Raspberry Pi, it has a firewall built into it, I plug it to my home network, my other hand friends can make voice over IP phone calls to me over the mesh network. It's cool, it's fun, but if I just say, okay, I'm good to go, and I never look at anything again, you might not realize that something is happening that you didn't plan for or didn't configure for. So that's where the last layer of defense for you comes, is monitoring, okay? Looking at logs for logins, looking at traffic monitors that report when a piece of traffic is denied through your firewall or some other facility, okay? So again, on the link on the bottom of the first page, this is a hot link. Well, I mean, it's an active link right now, that if you have a Raspberry, I think it's a Pi 2 or higher, it's a whole build to build with your Raspberry Pi a firewall with a complex firewall rule set. It has Snort on there for intrusion detection, and there's a logging facility on there so you can log when a malicious thing happened to your network, okay? And that's really the basics of it. I mean, the mesh network is really cool. I haven't set one up, but I've been reading about them. I think they sound like they're a lot of fun, but there is a security impact to allowing anybody to connect what probably ultimately will be at least your home network. So if you don't have security in mind, you're setting yourself open for exploits.
So now what if you, and I know I have a mesh network being built. I'm building one right now. Just it looks similar, but mine does not hook to my home computer.
Okay.
Or I have it disconnected from my home computer.
Okay.
So that it's standalone.
Okay. Yep. That's excellent.
Is that the way to go? I mean,
well, I mean, it's the way to go.
When I plug it in, it has a firewall, and I plug it in to look at it.
Right.
But I never keep it hooked up.
Right. Okay.
But I like this Raspberry Pi idea.
Yeah. Yes.
That would help. But I set up, when I set it up, that I wasn't going to leave my computer vulnerable to it.
Yes, good. That's a very good realization. Yeah, absolutely.
Okay. I just want to make sure that.
Oh, absolutely. Because what you're saying is, I isolate, I unplug it when I'm not in use. And when I want to use it, I plug it in. I mean, that's the most secure networks in the world are networks that aren't connected to anything. Right. Okay, so that's a good idea. Yeah. But there's a way with more confidence you can build a device that gives you that peace of mind.
I like it.
So you can leave it up and running all the time.
Ryan, would it be possible for it to sniff out a Wi-Fi?
When you mean sniff out a Wi-Fi, what do you mean?
Say if you have a mesh network in your home, it could be a vulnerability of it being able to sniff Wi-Fi?
Any 802.11 compliant network card can be used to do a promiscuous mode capture of data into the wireless interface. So absolutely. I've got Kismac on my Macintosh and Kismet on my machine. It's a very, very popular over-the-air capture device. Even Wireshark these days, you can download Wireshark, select your wireless network adapter, and you can see the raw dump. The only thing Wireshark doesn't show you is the layer 1.5 control packets that are flying around wireless. That's what a Kismac type, or AirSnort is another one, would show you that lower level stuff. That's how you find, if you ever seen SSIDs can be hidden or visible. So like when you go to your Apple screen to connect to a new network, a name shows up. But if you click on hidden network, it doesn't show up on people's computers. Well, that's just a bit that's set in the control frame for the wireless node. So with a sniffer like Kismet or even AirSnort, you can.
They've even shown these Vizio TVs, connect into your home Wi-Fi and see what channels you're watching.
Oh yeah, absolutely. Well, but if you think about it, it's a communication network. It's built to enable communications, and they do that very well, right? What you just the security mindset is thinking, well, everything's not trusted until I trust it, and that's really what you're trying to do is have some semblance of control. Does that make any? Did I answer your question? Okay.
Yeah.
Yeah. Okay. Yeah. So that's really my presentation. Not too in depth, not too deep. I haven't built the Raspberry Pi device yet, but I like it. I went online and researched. I found about 4 or 5 different walkthrough builds. This is an 11-step one. I would give this an intermediate to intermediate advanced type of an install. There's a lot of packages. There's quite a bit of config in the firewall end, so understanding your IP network and how it's configured is what you need to make that work. So I'd say it's a little bit more advanced, but I think a regular user could get a lot out of it. So that's some of the security impacts of a mesh network. So that's my best melding of data and ham. Is that like a sandwich? Data and
great idea.
Data and ham. So very good. That's about it. If anyone's curious, I do have some handouts that I just thought were interesting. If for next week's, tomorrow's or next week's discussion, it just shows the bandwidth, and the band, the channel allocations for Wi-Fi, and what some of the overlapping channels are and what they aren't. So just a little bit more specifics on Wi-Fi itself. If you're interested in it.
Can you email it to us?
What was that?
Can you email it to us?
I sure can. I sure can. It's from Wikipedia, one of my favorite sources of information, right? Yeah. Oh yeah.